So this is 6 dash, we're not in 6 anymore. This is 10-3 continue. I don't know when you're going to be listening to this, probably Thursday, Tuesday, Wednesday you're going to be testing, so probably Thursday would be my guess. So that's 6-3, go and write that at the top of your page. We are going to be talking about space. Did you like those that graphics there? How they dissolve in like that? Space is the set of all points in 3 dimensions. That's what we live in. We live in space, open space, closed space. We live in some sort of space inside of 3 dimensions. You have 2 different ways to represent 3-dimensional space. It should come off about 30 degrees, something like that, where you could label this X, Y. So this is going to be X, Y, and Z. That's one way to label that. A lot of people are more comfortable with that because we're used to the X and Y axis being horizontal and vertical. But one of the other standard ways is to have X come out of the page, Y be to the right, and Z be up. For this geometry class, we are going to be using this method because you're going to end up seeing both methods at some point, probably in your life. But I want you to be able to see this method, because if you don't ever see this method and you're just used to this method over here, you're going to get yourself confused. So that's the way this works. So if we were to do this here, where this is X, Y, and Z, you remember that we have our ordered pair, which is X, comma, Y. That's our ordered pair. Well, now we're going to be working with what they call an ordered triple. And an ordered triple is pretty simple in the fact that it has 3 points, your X and your Y and your Z location. And so then we say X, Y, alphabetically X, Y, Z will give us our ordered triple. And from there we can figure out where that location is. So with the ordered triple, if we go ahead and mark up some spaces on here, you're going to end up wanting to draw this yourself. You can't really get graph paper for 3-dimensional space, so you just kind of do it yourself. So we'll say 1, 2, 3, 4, 5, 6, and then we go up 1, 2, 3, 4, 5, 6, and then out. Positive 1, 2, 3, 4, 5, 6. Coming out of the page is positive, going into the page is negative. So if we come out 3 for the X, the first one is X, so we come out 3. So we come out 1, 2, 3. That's our first location, right? And then the next one is Y. So we have to start from that location. We go over 1, 2, right? 1, 2. We came over. We want it to be horizontal to the y-axis. So we came over to there, right? And then we go up. We go up 4. So then we go, there's 1, 2, 3, 4. So we're right here, right? And so that is our coordinate point at 3, 2, 4. That point right there. So a lot of work to get there. 1, 2, 3, 1, 2, 1, 2, 3, 4. So we do that again and again and again. So we want to draw this here. And you should not see that. I don't know why it popped up right there. They want us to draw it. So we are going to draw it. So I'm going to back up a space. And now we're going to draw it without that. So first things first is we draw out I probably went over too far a little bit. We draw this out. Draw, that was our z-axis, our y-axis, and now we have to draw our x-axis. Like about 30 degrees coming out of the page, right? And then we label these x, y, and z. X, y, and z. So you're probably going to want to get a ruler. I'll go ahead and let you go grab a ruler. I'm going to wait a minute by pausing. So I paused, waiting for you to get it. Well, there's no point in me pausing for you to do it. You're going to have to pause to go get it. So I'll let you pause. All right, so having drawn all of that, we want to draw starting with one vertex here at 0, 0. So we have one vertex here, right? At 0, 0. So one vertex at 0, 0 is what I said, right? So we're either going to want our box coming out of the page or we're going to want our box going into the page. And I think coming out of the page makes the most sense because then we don't have to deal with negative units. So we can just do with positive units. So we're going to come out of the page. So if we come out of the page with length of 5, and we'll call that x, and width of y, and height of z. So we come out 5. So first we're going to need to label these 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So we're just gonna end up getting these sides here. We come out 5. 1, 2, 3, 4, 5. So we're gonna do this point right here, right? And that is 5, 0, 0. Right? Because on the x-axis. And let's go ahead and get the other axes, and we come over 3, 1, 2, 3 on the y. That puts us there. We'll go ahead and plot these in like this. And this is going to be 0 on the x-axis, 3 on the y-axis, and 0 on the z-axis. And then let's do the z-axis. And we're going to go up 4. 1, 2, 3, 4. That plots us here. It's going to be 0 on the x-axis, 0 on the y-axis, and 4 on the z-axis. So that's that point. And then we got to come here, over 3 here. 1, 2, 3. So that point right there. And that's going to be 5 on the x-axis, and 3 on the y-axis, and 0 on the z-axis. That's that point. And then we're going to need to come up from here 4. So 1, 2, 3, 4. So that's going to be 5 on the x-axis, 0 on the y-axis, and 4 on the z-axis, right? That's that point. And then we're going to need to come up from here, right? And we need to come up 4. So 1, 2, 3, 4. Right, probably right about there. Needs to be parallel or close to parallel to the y-axis, right? Because that is going to be 3, 5, 3, 4. This is going to be 5, 3, 4. 5, 3, 4. Label that. 5, 3, 4. That's that one. Now we have one more point. That's going to be this one right here. So we come up 4. 1, 2, 3, 4. That is going to be 0 on the x-axis, 3 on the y-axis, and 4 on the z-axis. That's that point right there. So now, if we graph that, let's go ahead and graph it in blue. We have this right here. And that should be like vertical, right? So I was off just a little bit on there. So do you see that box there? You know, this right here would be kind of invisible because it would be hidden by that box. So we would just have this right here. And then these would be dotted, right? Dot, 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 dot. And dot, 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 right? And then we end up with something that looks like that. And that's what we did. So now we're to graph a cone with radius 3 units, height 5 units, and the base centered at 0, 0. So the first thing we do is we grab our ruler, draw our vertical line, as straight as you can, right? That's why you grabbed a ruler. Your horizontal line, and then your diagonal line, about 30 degrees, right? So now you have that. Go ahead and label them. X, Y, and Z, right? To the up is positive, to the right is positive, and out of the page is positive. So then we label these. We'll do 3, we'll do 5 units. Seems to make good sense there. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And 1, that's a bit high. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So now we have those. We want a radius, a cone with a radius of 3 units and a height of 5 units. So the height of our cone is going to be right here, right? So that's the height of the cone. So we have a base. Base of the cone is going to be a circle like that, and the height is going to be like this. So it's going to come down like this, right? To give us our cone. So that's the height of our cone. So we know everything is going to come down, and our radius is 3 units. So we come over 1, 2, 3. So we're going to be right here. And then we're not going to go down negative at all. So we don't necessarily need that. And then we go 1, 2, 3 over. 1, 2, 3 out, and 1, 2, 3 back. So this is our cone, right? So, man, I cannot draw that. Really struggling here, guys. Let me twist this thing a little bit. There we go. A little bit much of a curve there. I don't think I'd have so much trouble if I was on paper, but I'm drawing this kind of blind, right? Because I don't get to necessarily see what I'm drawing. I just got to draw it on this pad and watch what's happening. So then that's the way this works right here. And then if this were to come back down like that, and these edges that I'm drawing from the top don't actually exist, because remember, a cone doesn't have edges. There are no edges on a cone. It's just kind of an idea of how you would draw it. And so this is how they drew it right there, which is kind of similar, but you noticed this line here is not quite as steep on mine. The next thing that we're supposed to do is we are going to find, using the distance formula for 3 dimensions and the midpoint formula for 3 dimensions. So it's all just going to add more points. You notice here how our coordinate point right here is no longer a coordinate pair, it's now a coordinate triple. A coordinate triple, and the midpoint is also going to be a coordinate triple. So when we go ahead about doing this, instead of just ending at the y, it continues on to the z. So now you have 30% more work to do. 30% more work to do because you also have the z's. It's the exact same equations you just had. Comma, z plus z2 divided by 2. Remember, take the average of the points on the z coordinates and you divide them by 2. Take the squares of the differences of the z points and you times them, and then you add them to the other 2 units. And then this here is just essentially what we did the day before last. D is equal to the square root of L squared plus W squared plus H squared, right? That's the exact same thing that we did, only now we're using the coordinate points instead of this, because x squared minus x1, or x2 minus x1 is equal to the length, because it's the distance from here to here is the length of that side. So go ahead and write those down on your board, on your paper. This and this, you should have been writing that down to begin with. If you don't get it, you can go ahead and pause and write it down. You can also find it in your book. So we need to find the distance between these points and the midpoint. So there's a lot of work here. So the first thing you do is you write out the distance formula, which is going to be x2 minus x1 squared plus y2 minus y1 squared plus z1, or z2, doesn't matter really, z2 minus z1 squared. So that's that. That will be the distance formula. So we go ahead and need to label these x1, y1, and z1, and x2, y2, and z2. So I want you to make sure you write those down on your paper. 095 and 6012. Get those written down. So now's the part where I've been talking to you the whole time, right? And you're like, Mr. Seekins, why are you not asking any questions? And I'm glad that you were thinking that, because I'm going to ask you a question. So Lucas, and you knew I was going to call on you, Lucas. And Casey, quit laughing at him, because we all know that you're going to be next. So Lucas, what is our x2? Glad you see that up there, because I know you wrote it down. And when I say I know you wrote it down, I know you didn't. 6 minus x1, 0 squared, plus y2. y2 is going to be 0 minus y1, which is 9. Casey, quit talking to him. Plus z2 is going to be 12 minus 5 squared. So this is going to be 6 squared plus 9 squared, or negative 9 squared. Does not matter because once we square it, everything is inside of parentheses, and once you square it, a negative becomes a positive. And then 12 minus 5 is, what is that, 7? 7 squared. So then 36 plus 81 plus 49. So D is equal to that. So you add all of that up and you get D is equal to the square root of 166. Round to the nearest tenth. So we do not need to leave it in simplest radical form. So we go ahead and take the square root of that. And we end up with 12.884. Or approximately that, because I'm not writing all of them, and then that reduces down to 12.9, right? Round to the nearest tenth, so 12.9. Now we need to do the midpoint formula. In the midpoint formula, m is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma, z1 plus z2 divided by 2. So we go through this, and I can just look right here. I have them right there, so that's going to be 6 plus 0 divided by 2. 0 plus 9 divided by 2, and 12 plus 5 divided by 2. So 6 divided by 2, 9 divided by 2, and 17 divided by 2 gives me 6. And then we'll go ahead and round those to the nearest as well. So that gives you 4.5 and 8.5. So that's our midpoint. So that's that. So we can go ahead and go on to the next one. I'm not going to go ahead and walk you through this. We just seen an example of this. So we'll go to the next one, example 5. Trevor. Thank you, Trevor. He drove 12 miles east and 25 miles south from a cabin. So we're going to go ahead and draw out our coordinate grid. So we can go ahead and label these elevation. We'll label this north. We'll label this south. And we'll label this east and west, right? He drove 12 miles east. Elevation, right? So we'll just say height. Seems to make the most sense. Height, he drove starting here. He drove 12 miles east. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 25 miles south. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? So now he's at an elevation of 0.1 mile, so just barely above, right? So like right here. And so he didn't go up at all. So that's pretty much just a distance formula, right? Because his elevation didn't change. And then Sam drove 8 miles west. 1, 2, 3, 4, 5, 6, 7, 8. And 17 miles north. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right? So 17 miles north. That's 19, so right here. And gained 0.15, so up like right here is where she went. So he drove from here, whoops, let's try this. He drove from here to here, and she drove from here to there. So how far apart were the drivers? So we want to know this distance here. How far apart were the drivers? And so then we don't even need to know the rest of the stuff. We just do the distance formula. I just did that so that you got an idea of what was going on. So let's go ahead and label these points though, so that we can see it, so we can know it, so we can have our coordinate triple. So we go like this. So she drove, this is our y. So let's do our z or x first. So she drove negative 17 and then negative 8 and negative 8 and then 0.15. And he drove how much out of the page is x first, so that's 25, comma, and then drove 12, comma, and then he is at 0.1. So now we have those points. So we'll go ahead and keep those points and get rid of everything else. So these are our coordinate triples. If you could have figured that out without having to draw everything else out, then that is good. Part of drawing it out for me was to figure out what was going on so that I could look at it all and make sure that I got it all right. So we want to find out how far the drivers were apart. And it didn't, in this case, it doesn't really matter which one you would have picked to be your x, your y, and your z, your x, your y, and your z, as long as you were consistent with them, so that your west and your east would have, if your west came first, then your east would have came first. And I don't know if I'm confusing you or not, so I will stop talking about that. So y1 or x1, y1, and z1, x2, y2, and z2. So then we go ahead and plug that into our formula. So d is equal to the square root of x2. And remember, I want you to write the formulas out every time. x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Now we plug these in. X2 is 25 minus a negative 17 squared plus and y2, 12 minus a negative 8 squared plus 0.1 minus 0.15 squared. When you subtract a negative by a negative, you get a positive, so 25 plus 17 is 42 squared, plus, when you subtract a negative, you get a positive, so that's 20 squared, plus a negative 0.5 squared. So 42 squared is 1764 plus 400 plus 0.5 squared is going to be 0.25, so we add all of those up, and that gives us 2164.25, square root of that, and that puts the distance at 46.52 miles, right? So that is good. That's all we were trying to do. They're 46.52 miles apart. Or we would just say, well, they're approximately that anyway, because we took the square root of that. So we would just say they're 47 miles apart. Because when we talk about miles, I mean, they're talking about point something of a mile here. So maybe they want us to keep this. So I guess maybe we keep that because that's what they're keeping. But I would have just, if it was me, I wouldn't even cared about these, right? How far apart are they? The difference here is 0.05 mile high. So I would have just said 47 miles apart. Would have seemed pretty close to me, because that's how I measure things. And I'm not going to measure in quarters of a mile. All right, so that's that. So I will go ahead and give you your homework. So your homework is going to be on 674, and is going to be 21 to 27 all. It's going to be drawing three-dimensional shapes using the space, which is X, Y, and Z, and then calculating the distance in the midpoint, and then using kind of a real-life situation to do that. Hope you had a good day. I talked about the fourth period class, so now I should talk about the fifth period class. Bradley, get to work. Quit laughing. Thank you.